we look at this example, it'd be wrong to think that when we do the integration here, we just find the integral of x and then find the integral of x squared plus 4 and then just put them as a numerator over the denominator as an answer. Just as when we did derivatives, you couldn't just find the derivative at the top and the derivative at the bottom, put your answer down. We had to use a special rule. So when you've got this scenario happening as well, where you've got a function and a function, you can't just find the integral of each of the individual functions and then put it as a numerator divided by a denominator. So what would make it easier? It would make it easier if we just let this one equals u. So another example of integration by substitution. So our first step is to find a suitable substitution. So we'll let u equals x squared plus 4. And we do the template. So then we've got du dx. Now du dx in this case is equal to the derivative of x squared is 2x and the derivative of 4 is 0. So we get that. And what we're going to do is use substitution. So we're going to substitute for that dx. So we're going to get dx by itself. So we just switch those two around and we get du over 2x equals dx. So that will allow us to do that. It allows us to substitute for there. Don't worry about that x there by itself because you'll see what happens when I do the substitution. We don't have a definite integral, so we don't have lower and upper. So this is the step in the template where we have to calculate the u values is not necessary because we don't have values set there. So this is going to be a plus c example. So what we do now is to make the substitution. So this integral that we're asked to do, x over x squared plus 4 dx, will be equal to, now we do the, as I said, there's no upper and lower, so we do the substitution without upper and lower. We just leave that x there as itself, over, now what is x squared plus 4? We let that equal u, so that'll be x over u, and then we do the substitution for dx. Now dx in this case is equal to du over 2x. Now you can see why we haven't had to worry about making a substitution for x, because what's going to happen here is that these x will cancel each other out when we cancel. So if it doesn't happen that the x's cancel, and you just don't get something here all with u's in it, then it's not going to work. So you made the wrong substitution, or the substitution won't work at all. So here we've been able to get rid of the x's. So this has become an integration just with u's in it. So we've got the integral of 1 on u du. And that is easy to do. From your table of integrals, you know the integral of 1 on x is ln x. So the integral of 1 on u with respect to u equals ln u. Now it's an integral, an indefinite integral, so we've got to put a plus c there. The original question did not involve any u's in it, so we've got to do the back substitution. So where we've got this u, we've got to put an x squared plus 4. This was an integral with respect to x, so it's wrong to give our answer. We introduced the u, so we've got to go back and now and do the back substitution. So what was u equal to? U was equal to x squared plus 4, so that'll be ln x squared plus 4. Now the constant is just our constant of integration. So that's how to do slightly a little bit more difficult, because when you find du dx, you actually get a term in x. And so when you find dx by itself, you've got du's and dx mixed up here. But you should find that if you've got an x there, it's going to cancel out with something else that's already in the original integrand. And indeed it does. If it doesn't, you've made the wrong substitution, or it doesn't, the process or the technique doesn't work. And then this should simplify and away it goes. maybe at this stage I'll just show you where it doesn't work. And if you say you've got the integral of sine of x squared plus 9 dx, and you would say, all right, we'll say let u equals x squared plus 9 du dx equals 2x, and then we get dx the subject, so switch those two around, we got du over 2x, so we switch these two around, put the 2x underneath, and dx goes up the top. And then when you do the substitution, you get the integral of sine, now u is equal to that, sine u, and then instead of that dx, we will put du over 2x. And the x's won't cancel. So we can't go any further than that, because you can't just do the integral of sine u with respect to u, because u is a function of x. So these u's and x's are linked to each other, they vary. So we cannot just do that integration with that 2x there. X is not a constant, so we can't just take it out the front. The 2 we could, but with this x has got to stay inside here. So integration by substitution does not work, and we would have to use some other sort of process to do that, which will be covered in Maths 1B. So it does not work in this situation. The x's have got to cancel out like we've had up here for it to work.